It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Welcome to Unacademy and welcome to Unacademy Semester Exams. We are dealing with the control systems quick revision session, Chapter 1. Yesterday we have seen Chapter 1 first part. As a part of Lecture 2, we will see the second part, useful for the semester exams. So before that, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and ESE and also cracked GATE. Unacademy, let's crack it. Crack GATE and ESE with India's largest learning platform. Get subscription. You can install Unacademy learning app from Kalyan Khan. Good evening. Unacademy learning app, you can install it from the Google Play Store and you get the daily live classes, structured courses, live test and quizzes, unlimited access as well. Also, you get the personal coach, study tracker, mains question and answer and all the benefits in Iconic subscription. And in Plus subscription, you get daily live classes, structured courses, live test and unlimited access as well. You can learn from the top educators of the Unacademy and you can also get GATE and ESE batches, year-long courses. You have almost all the specialization with all the courses and you get all the benefits of Plus in Iconic with special benefits like personal coach, personalized test analysis, study planner, etc. And to get subscription, you can go for Plus subscription. You can use my code YSK10 to get the discount on this, and this is for a limited period of time. And you can also go for the Iconic subscription. I suggest you to go for the 24 months. You can use my code to get the maximum discount on this, and which is for a limited period of time. So the topic for today is Chapter 1, Control Systems Quick Revision. Chapter 1 Part 2. This is Part 2. Let me revise what we have done yesterday, then we'll move on to the today's topic. Hi Rachita, good evening. Now, Unit or Chapter 1. In Chapter 1 we have seen yesterday what was a control system and its classification, the basic thing. We have seen some questions that are previously asked in the exams. Then we have seen what was feedback and its types, also its effects. Now third one we have seen was transfer function, its advantages and disadvantages or limitations. Transfer function and its limitations. And fourth, Hi Soumya, welcome to Unacademy. Good evening Soumya, good evening. Transfer function and its limitations. Then I told you about the mechanical system. We have taken this course is just basically for the semester exam students, and they can definitely clear the exam once they are listening to these sessions. Now today, this is a part A of chapter 1. Now let's look at the today's one. So today we'll see unit or chapter 1 second part B, chapter 1 part B. Now today we'll look at what is block diagram reduction technique and mathematical model of electrical circuit or electrical network. Third, we'll see a signal flow graph, and we are not going to discuss in detail, but we will just look at the important questions that are previously asked in the university examinations and try to solve them. This is just a question and answer session, not question to answer, it is question and answer session. So before that, I'll just quickly review some of the things, not all. I'll just review. First we'll start with block diagram, then we'll enter into electrical network, then we'll use signal flow graph method. We'll solve some problems based on these three topics. Now let us start with block diagram reduction technique. So I'll just take one question. Before taking that question, I'll give you just review of block diagram reduction technique. So first I'll give you a just quick review of this block diagram reduction technique. Right. This block diagram reduction technique has some set of rules, and the first rule comes out to be, so this block diagram is actually the representation, the pictorial representation of a given system, right? So it has some set of rules. The first one is cascade, right? So before this cascade, let me also tell you something. What are the things that we use in this block diagram? You need to understand some terminology, like we will use something called as summing point, which is used to add or subtract the signals. This is the symbol. This can be entering, leaving, entering, and so on. This can be plus or minus, and so on, right? X, y will give you x plus or minus y, minus plus or minus x, plus or minus y. And the second one is, you take a block, right? You have something, a block which represents the gain of a system, gain of a block. We'll call it as G1, we'll call it as G2, and so on. The third thing that you have is a takeoff point or pick off point. It is also called as pick off point. That means, let us say you have a signal, a gain of a system or block, then you will take some signal from here, and this is nothing but the takeoff point. This point is called as the takeoff point. Rakesh, welcome. So these are some of the things that you need to understand. Now let's look at the rules of block diagram. I'll just tell you few rules. The first one is cascade. If there are two blocks that are in cascade, what happens? This is a block, this is another block, G2, and let's say this is G1. So this G1 and G2, if they are in cascade, you can represent it as G1 into G2, G1 into G2. This is the equivalent. Now let us say you have the second one, two blocks are in parallel. Let us say you have two blocks are in parallel. So when do we say two blocks are in parallel? If the gain is given to a summing point, you have another gain G2 that's also given to the summing point, and let us say I'll call this as plus and this as minus. Now what happens is, if you have something like this, you can represent it as equivalent of a single block. Now this will be, the resultant will be, this is G1 is minus, G2 is plus, so you can write minus G1 plus G2, right? That depends upon this. Good evening minus G1 plus G2. So these are some of the, this is how we write the two blocks in parallel. You'll have some input X, you'll have some input Y, you'll have XG1 plus XG, YG2 and so on. Right. Now the third one is you have feedback path or feedback loop, you can say. Now if at all you have a summing point to from which a signal is going to a block of G1 and we are taking the signal from the output of this block and giving it to this input of this block H1. Now if this is minus, we'll call it as a negative feedback, and therefore we can represent this as equivalent of a single block which has a value of, you can write G1 by 1 plus G1 H1. If you have a minus here, you'll have a plus. If you have a plus here, you'll have a minus here. So this is feedback loop. Now let's go to the fourth one. Now let us say you have a block here G1. You also have another block G2, and you have taken some signal out of this point. Let us say this is X. And what is the point here? You get signal xg1. So what is the output of this xg1? Now if I want to represent this, now for this g1 and g2, for this g1 and g2 to be in cascade, see, for this g1 and g2 to be in cascade, for this g1 and g2 to be in cascade, this takeoff point is disturbing it. So we'll have to take that. So what I do is I'll write g1 and G2 and I'll move this takeoff point after this block. That means I'm moving this after this block. Now this is this one. Now what is the input to this X? What is the output of this XG1? Let us say this is a signal flow. Yeah. What is here? X, G1, G2. But this takeoff point should take a signal of XG1. It should not take a signal of XG1, G2. Karthik Jilla, welcome. Welcome to Unacademy. So this G1, G2, but it is taking Xg1, G2 because it has to take only Xg1, but it is taking Xg1, G2. So what I'll do is I'll place a block here of 1 by G2. Now what is the output? Xg1 is the output. So it is taking the same signal. So the statement here would be something like this. You'll write it: whenever a takeoff point is moved after a block, then add 1 by gain of that block in takeoff path. That means this path, right? So now let's look at the fifth one. Now the same thing, you have this G1 and this is G2, and if somebody says that I don't want to take the signal from here, I want to take the signal from here, but this is X, this is G1, I don't want to move it after G2. Why can't I move it before G1? Yes, we can also do that. So what we'll do here is we will move this before G1. Then what happens? Now look at this, I'm moving this before G1. This is G2. Now if I move this before G1, what is the signal that is taken by this takeoff point? It is taking X. This is X, right? Now previously it is taking Xg1, now it is taking X, but whenever I change the position of this takeoff point, the signal that is being taken by this takeoff point should not change. So what I do is I'll just place here a block of G. So now what is the signal taken by this takeoff point? Xg1 or G1 if I take. Now it is same. Now this is the statement that we get. Whenever a takeoff point is moved before block, then add gain of that block in takeoff path. So this is what you have to write. Now similarly the case with the summing point also. Okay. Now let us take a summing point. Sixth one. Let's take, you have a block G1. This is the summing point. Now let's take, this is X and this is Y. Now I'm giving plus and plus. What is the output of this? This is xg1 and this is y. So this is xg1 plus y. Now if I want to move this summing point, let's say you have another block here g2. So in order to make g1 and g2 in cascade, I want to move this before g1. I want to move this before g1. So what is that? I get a summing point here. What is the input to the summing point? X. And what is the other input to this? Y. And what is this gain? G1. And this is G2. Now G1, G2 are in cascade, right? When I move this summing point before this, G1, G2 are in cascade. Now in order to make that, I have moved it. But this summing point, the receiving signal to this summing point should not change, right? So whenever this is having, what is the output of this? X. Now this is xg1 plus y, right? So you need to get xg1 plus y. So you need to take that x into g1. Now let's look at, this is moving a summing point before and after the block. Now let's say we have one question in the university exam that is asked. Question, let us consider one question. Obtain the transfer function. Question is, obtain the transfer function obtain the transfer function y of s by u of s for the following block diagram. Block diagram is given something like this. You have a summing point, you have a G1 and another summing point, you have G2, there is another summing point, a G3 is given and a G4 is also given. This is y of s and this is given after G3. Let's say this is given after G3 here. Now there is another feedback here with H1 that is given to this point, and you have another feedback that is given as H3. Right? So this here it is given as plus and minus. This is R of S, and you also have summing point plus and plus here. This is also minus and plus here. Here you have one more point. This is given as H2, right? And then you have, yeah, this is the block diagram. Now if at all you look this block diagram, the first thing is, the doubt that you get is where to start the solution. Where do you have to start the solution? Just look at this. Where do you have to start the solution? Just look at if the blocks, whether there are any blocks that are in series or cascade or parallel, that you have to look at if they are in cascade. Now let's look at these two, G2 and G4. If you look at this G2 and G4, they can be in cascade, but there is a takeoff point. If I move this takeoff point after this block, what happens? I can make these two as cascade. So I'll do that. The first step is, you should write it something like this. Moving a takeoff point after what? G4. After G4. Now what I can do, that I can redraw this. I'll just try to redraw this. This is G1, another summing point, G2, summing point, G3, G4. Now you have this feedback H1, there is another feedback H2 here. Now we have moved this to this point. It was previously at this point. Now we have moved this to this point. So this is G2, G3, G4. This is H1, H3. Right? So this is R of S and Y of S. This is plus, minus, minus, plus, and this is plus and minus. Now we have moved this, but whenever you move this to this point, the actually previously when you look at this, the signal that has to go to this was G3. Let's say this is X, so it is X G3 to H2. But what is that now? It is going G4 also it is going. So what you have to do, you should take a block here. You should take a block here and write 1 by G4. If you now just look at this, if this is X, what is the signal that is going? X, G3, G4 is the signal that is entering. But what is the output of this? X, G3, because G4 is cancelled by this, right? So it will be same as this whenever you move it also, right? Now this is what is moving a takeoff point. Whenever you move a takeoff point, you need to multiply it with the reciprocal of that. You need to multiply it with the reciprocal of that block, right? So now can we make this? Just look at this. Can I make this 2 as cascade? Yes, you can make these 2 as cascade. That is the second step that you need to write. So write the second step. Second step is cascade blocks G3 and G4. Cascading blocks G3 and G4. Now let's try to cascade that. So this is the summing point G1, summing point G2, summing point. I'm just writing one block instead of these two. That is G3, G4. This is Y of S. Now let's try to move this a little up. Let's see. So there is one feedback here, H3. There is another feedback. No, it's not at this point. At this point you have, this is H1, and you have a feedback here with 2 blocks now. It has 2 blocks. So this is H2 and 1 by G4, H1, H3. This is R of S, this is Y of S, plus, minus, and plus, minus. Right? Now these two have been made a block. Now if you look at this, can I make this as a feedback path? See, look at this. This is a feedback. Now this is the signal that is going like this and coming here like this. So you need to write the third step. This was the second step. Write third step. What is the third step? Eliminate. You need to write something like this. Eliminate feedback. What is the feedback that you have? Just look at that. G3, G4 and H1. G3, G4 and H1. You have, see, you have a G3, G4 like this with a summing point, and H1 like this, and it is minus here. Now if you just want to eliminate this, you need to eliminate the summing point, this block, this block. So the equivalent of this is a single block with value G3, G4 by, because this is minus, you will get 1 plus G3, G4, H1. So replace this part with this. Can I do this something like this? No, let's try to draw it once again. So you have a summing point, a G1, then a summing point, then after this summing point you have G2, then you have, after G2 you can eliminate this block, right? So you need to eliminate this block. So this is the new block. What is that block value? G3, G4 by 1 plus G3, G4, H1. Now this is G2, we already know. Now after that you have a line like this. Here it is taking H1 and 1 by G4 and a line. And to this you have H3. We have eliminated one feedback. So this is R of S and this is Y of S. Now can I say, see, you need to eliminate this summing point also. Remember, you need to replace these three things by one block. Now when you do that, can I say G2 and this part are in cascade enough, and H1 and 1 by both are, see, this is the signal that is being taken. Can I say this is plus, yeah, this is minus, this is plus, yeah. Can I say this G2 and G3, this completely is in series or cascade? Now eliminate this cascade. Also these two are also in cascade. So what I'll do is I'll combine these two blocks and also these two blocks. Now let's try to do that. So I'll just do it here itself so that it will be easy for us. Now let's look at this. You have a summing. What do you have to write? You see, we are writing some steps, right? Fourth point. What is the fourth point that you want to write? So fourth point is combine blocks in cascade. Now let's try to do that. This is G1. You have a summing point. Can I make these two as one block? What is that cascade? Multiplication. G2, G3, G4 by 1 plus G3, G4, H1. And also if you see, this is also a cascade block, right? What is that? H1 by G4. And you can combine them. And this is the feedback loop. This is Y of S and this is R of S. This is plus and minus. This is plus and minus. Now if you observe this, this part is in feedback. This is in feedback. So let's try to eliminate that feedback. I hope you are able to understand. Eliminate feedback. How do you eliminate that feedback? Let's try to take this summing point. This is G1. So instead of all these, see, you need to replace including this summing point. Including this summing point, you need to replace this summing point along with these two blocks. This is forward path, this is feedback, by a single value. What is that value? I'll just write it down. See, this is now G. This completely is G by 1 plus G into H. So this is G2, G3, G4 by 1 plus G3, G4, H1 by, this is G, 1 plus G2, G3, G4 by G3, G4, H1 into H is H1 by G4. So this is the feedback. So you'll write, let's say this is X and this is K. You'll write X by 1 plus XK. This is what you have to write. X by 1 plus XK. So X by 1 plus X into K. Right? Now you need to replace that by this block. So let's try to replace this. Complete. Including summing point you will have to replace. That's what I'm specifying. So what is this value now? It is, you can cancel this 1 plus, right? This is also 1 plus, yeah. So if you take LCM and cancel it out, what do you get? G2, G3, G4 by 1 plus G3, G4, 1 plus G3, G4, H1, G4 plus G2, G3, G4, H1. Let's see if there is some calculation mistake also. Now this is the feedback again. Let's try to simplify this easily. You'll get it. This is R of S and this is Y of S. Now if you observe this, these two are in cascade, right? So what I have to do, I have to combine the blocks in cascade. Combine blocks in H3 was missed. H3, yeah, very good. This is H3. Yeah, let's consider this as H3. Yeah, you already have a H3. Very good. Very good, Kalyan and Meghana. So combine blocks in cascade. So we are combining these two. Now just multiply this. So G1, G2, G3, G4 by 1 plus G3, G4, H1, G4 plus G2, G3, G4, H1. Right? and you have a feedback. What is that feedback? H3. Now this is R of S and Y of S. This is plus, this is minus. Now you can say that this is again a feedback path with a negative feedback. So you can combine this with one block, right? So you can write complete one as a single block, R of S and Y of S. Now let's see. So this is G1, G2, G3, G4 by 1 plus G3, G4, H1, G4 plus G2, G3, G4, H1 by, this is completely X now. What do you get? X by 1 plus X into K. This is K, let us say. This is K. So we have to write 1 plus G1, G2, G3, G4 by 1 plus G3, H1, G4, G4 plus G2, G3, G4, H1 into H3. So finally, we just write it down. Y of S by R of S is equal to the term that you get here. So this will become the question, the transfer function Y of S by R of S. Therefore, you need to write transfer function Y of S by R of S is given by, right? We have considered H3 also, very good. Just thanks for reminding that. Also H3. So this is how you have to do. Now let's just try to look at this. Just try to minimize. Oh, hope you are able to see this. From the first step, I'll just show you once again. Yeah, it is visible, I guess. Yeah. Now this is the question. Just look at this question once again. This is the question. Now first what we have done, we have moved this takeoff point to this point. So 1 by G4 is added to this feedback loop. So that is H2 by G4. And now these two will be in cascade. So this is G3, G4. And these two are in cascade. So cascade blocks or combined blocks in cascade, you can also write it something like this: combined blocks in cascade, right? After that, we have eliminated the feedback path. Just look at this. Yeah, we have eliminated the feedback path. If this was the feedback, and we have eliminated that. And after that, you got this feedback path here and combine these two, cascade these two blocks. Then you have a feedback path. Then when you have this feedback path, we try to combine these two blocks in cascade. These two blocks are also in cascade. And this is the feedback path, and we try to eliminate that. I guess this must be 1 plus this. Yeah, 1 plus G3, G4, H1 into G4. Right. So this you'll get it. So take this 1 plus G3, G4, H1 into G4. Just try to simplify this. Maybe it may not be the exact value, but this is how you have to do it. Let's see, let's try to take this LCM. G2, G3, G4 by 1 plus G3, G4, H1 by 1 plus G3, G4, H1 into G4 plus G2, G3, G4 into H1 by 1 plus G3, G4, H1 into G4. right? This term will get cancelled, so we'll get G2 G3 G4 by 1 plus G3 G4 H1 into G4 plus G2 G3 G4 H1 by G4. This is what you get. So this is, you'll get in the numerator as G4. So this is the value. Just try to simplify that and you'll get this value. So yeah, just try to incorporate that value, and once you do this, you can just substitute it here, and these two blocks, now these two blocks will be in cascade. So once you combine them, just multiply that, so you will get a G4, one more G4, I guess. So these two blocks are in cascade, just combine them, then this path will also be in feedback here. If you look at this will be in feedback. We can combine them, x and k, x by 1 plus x into k, because this is a negative feedback. So this is again G4. So this is again G4, right? So finally you can just simplify this value. Just simplify this value and write it here. That will be the transfer function. So this is one question that is asked. So I don't want to write more and more about this block diagram. Let's move on to this signal flow graph. Yeah, see, just look at these rules once again. Yeah, we were seeing, yeah, this is block diagram, and after that let's see signal electrical network. Once we are done with electrical network, then we'll move on to this signal flow graph. So finding the transfer function, in all these three things, what you do is you'll find the transfer function. That's the only thing that you do, and there are questions that are being asked in your exam on electrical network as well as signal flow graph, electrical network and signal flow graph, and block diagram reduction also. So let's look at this electrical network. One electrical network question. Let me take one question. Yeah, this is the question that is given. Let me consider one question. Yeah, you can look at this question solution once. Somebody is asking me about it. Yeah, you want me to show step number 4? Yeah, this is step number 4. Moving summing point once again. Yes, so let's see, somebody wants moving summing point. Okay, let me tell you. Let's say you have a summing point. I'll just take a very simple example now. Maybe you did not understand there. So let's say this is plus and this is plus, and you have a G here. Now why am I doing this is, let's say you have a G2 and this is G1. You can actually listen carefully. You can actually make this G1 and G2 in cascade. You can make G1 and G2 in cascade, but because of this presence of this summing point, you are not able to make this cascade. Now what I want to do is, I want to just move this summing point after this G1. What am I doing? I'm moving, this is G2 and this is the, now this is G1, and now let's say I'm moving this after. Either you can do this way or you can also move it before. Let's see, first let me take very simple, that will be very easy. So I'm just first now eliminating this now. So in order to clear your confusion, I've just eliminated this G2 as of now, right? Now listen carefully. What is the output of this now? X. Let's say this is also plus, this is x plus y. Now what is the input that is coming to this G1? It is x plus y into G1. What is the output? xg1 plus yg1. Now let us say I want to move this after this G1. I want to move this after this G1. So this is G1 now, and input to this G1 is X, and here you have a summing point, and here we are giving Y, right? Now what is the output of this? This is XG1. What is the output of this? XG1. What is this? Y. What is the output of this? XG1 plus Y. But what is the output previously? It is XG1 plus YG1. Am I getting XG1 plus YG1? No, I am not getting XG1 plus YG1. So what I'll do is I'll add a block here, G. Listen carefully once again. So I'm just trying to add a block here. So this is extra block G1. Now what is that? You get YG1. What is the output? YG1. Is it same as this now? Yes, these two are same. So you can write, whenever you move a block, whenever you move a summing point, whenever you move a summing point after the block, add the gain in series or cascade here, right? So this is very important. It's the same way if you move it, just if you already have it here, let's say you are moving a summing point before. Let's consider once again, moving summing point before block. Now let us say you have G1 here, and let's say this is X, this is the summing point, you have a Y here. Now what is the output of this? This is XG1, this is Y. What is the output of this? This is XG1 plus Y. Now let me tell you, if I want to move this before block, because let's say you have a G2 here and you want to make G1 G2 cascade, so you want to move this before this block. So I'm taking this summing point here, this will be G1, and here you are getting output. Now what is the input to this? This is X, and this is Y, and this is X plus Y is the input to this G1. What is the output? XG1 plus YG1. But actually what should be the output? Actual output should be XG1 plus Y. What is the present output that you get actually? Present output is XG1 plus YG1. In order to do this, in order to convert this to this, what I should do? I should divide this Y with G1. So what I'll do is I'll add 1 by G1 here. Now what is the input to this? X plus Y G1. What is the output to this? X plus Y G1. Now what is the output? You'll get X plus Y by G1 into G1. This is X plus Y G1 into G1 will give you X G1 plus Y, which is same as this output. So you can say whenever you move before block, add 1 by gain of block. This is 1 by gain of this block, right? So this is moving a summing point before and after the block. Yeah, if you have understood, just tell me yes or no. Somebody was asking me about it, so I want someone to respond and tell me if you have understood this moving a summing point. Yes or no? We are moving on to the electrical circuit question. So the second question from one of your university questions is, yes sir, got it, very good. Determine the transfer function. Now determine the transfer function EC of S by E of S. EC of S by E of S. Right? So let's look at this for the circuit shown in the figure. For circuit shown in the figure, let's look at that question. There is an electrical circuit that's given. This is only one time that's given. Most probably it's very easy. So this is you can apply this. Yeah, this is the network. Let's look at this network. You have a resistor and an inductor and a resistor again. Then you have a capacitor, and this capacitor value is C, and the voltage across this capacitor is EC, and this is resistor R1, L, R2, and this is given as IL, and this current is IC, and this input is given as E. So what is the input of this system? First point is, what is the input of this system? Input of this system is E of t. Let's call this as E of t. E of t. Now what is the output of this system? Output is EC of t. Let's say this is EC of t. Now what is the Laplace transform? Because we are asked about the transfer function. What is the Laplace transform of E of t? This is E of s. What is the Laplace transform of this EC of t? This is EC of s. Yes? No. Second step. What is the transfer function? What is the transfer function you get? So transfer function is EC of s by E of s. EC of s by E of s. This is what you have to determine. EC of s by E of s. Either first thing that we can do is we can apply Laplace domain to this complete network. Right? Apply the Laplace inverse to this complete Laplace transform to this network, so that you will get E of s, R, Ls, R2s, 1 by Cs. Then you can apply the equations KVL or KCL, or you can do it in the other way, like you can write first equations to these two loops, then you can apply Laplace transform. So we'll do one method out of this. So let's consider that circuit once again. So this is the circuit, E and resistor, inductor with a resistor here and a capacitor. So this is the capacitor. So let's write the Laplace transformed network. So I'll just write Laplace transformed. Here you have E, so you can write it as E of s. This is R, and this will be Ls and R2 and 1 by Cs. This current is IC of s, and this is IL of s, capital I. And here the output is EC of s. Right? Now let us consider. Let's try to write the equation. I'll write the equations, and I want you to just simplify this. So first write IL of s equation. Let's consider the loop current in this as IC of s, because it is given IC. I am considering IC, this as IL. Now what is EC? E of s is equal to R1 into IL of s plus Ls into IL of s. This is a apply KVL. Just you need to apply KVL to this loop. Do you get this equation? Yes. To loop 1, this is loop 1. Now let's consider loop 2. Is this completed? No. This is R1 into IL of s, Ls into IL of s, plus you also have R2. So R2 into IL of s minus IC of s. So this is complete. How many elements? 1, 2, 3, 4. You got 1, 2, 3, 4. Right. So this is done. Now apply the same to the loop 2. What happens? This is 1 by Cs into IC of s plus R2 into IC of s minus IL of s is equal to 0. Do you have anything in this? No, you do not have. Now in this, what do you want actually? EC of s is what you require. What is EC of s? Can I write this as EC of s? Can I write this as EC of s plus R2 into IC of s minus IL of s is equal to 0? Right? You can write these two equations and whenever you do this equation has E of s and this equation has EC of s. Right? You can write these two equations, E of s and EC of s. Write these two equations. E of s is equal to R1 IL of s plus Ls into IL of s plus, take common minus here, you get this is minus or plus R2 into IL of s minus IC of s and divide by EC of S. You get by, you can write EC of S is equal to, what is EC of S is equal to? Minus R2 into IL of S minus IC of S. This is minus R2 into IL of S minus IC of S. You can write this way with I of S and IC of S, IL of S, and you can still further reduce this as now. Write what is IL of S from this equation. IL of S is equal to, what is IL of S? And IC of S. What is IC of S? You can say this is EC of S. So IL of IC of S is equal to EC of S by 1 by CS. Because you have a capacitor and the current through it is IC of S and the voltage here is EC of S and this value is 1 by CS. You get IC of S is equal to EC of S by 1 by CS. And what is IL of S? IL of S is the current flowing from this node to this node. What is here? EC of S and this is E of S. So you can write this is resistor, inductor, and what is the current flowing through this? This is IL of S. This is E of S and this is EC of S. So IL of S is equal to E of S minus EC of S by, this is R and LS, R plus LS. So replace these values of IL of S and IC of S in the above equation and you can simplify. Right, so this, if you have a network that is given, you can also do this way, or the other way of doing this is, let's say we have a resistor and an inductor and a resistor with a capacitor. Now this is C, voltage here is EC, this is R2, R1, L, you have E. Let us consider this equations in time domain. E is equal to, let's say this is IL and this is IC. I into R1, IL into R1 plus L DIL by dt plus R2 into IL minus IC. This is first equation. Second equation, EC is equal to, now second equation, second loop equation, you can write R2 into IC minus IL plus 1 by C integral I dt is equal to 0. Now apply Laplace transform to this. You can also write EC. What is EC is equal to? It is 1 by C integral IC dt. So you can write this as EC is equal to. You can apply Laplace transform to this and Laplace transform to this. Simplify and you will get the transfer function required. Right? This is another way of doing. Either you can write the time domain equations, write the Laplace transform, then apply it, or you can also write the Laplace transformed equation circuit and then you can do it. Now let's move on to the signal flow graph. Now signal flow graph is based on Massen's gain formula. This is based on Massen's gain formula. C of S by R of S is equal to 1 by delta Pk delta K. So this P is number of forward paths and K is, right, well, like this. This is forward path gain. E is forward path gain. K is number of forward paths. Number of forward paths. So in order to understand the signal flow graph, Raju, welcome. Right, in order to understand the signal flow graph, you need to understand few terms, that is forward path. What is a forward path? It starts at an initial node and terminates at final node. This is one point. Next, you need to know individual loop. You need to understand individual loop. That is a path that starts and ends at same node by traversing the rest of the nodes without traveling. For all these, the one condition is that it should not traverse any other node twice. Then non-touching loop. Non-touching loop. What is a non-touching loop? If two loops doesn't have a common node, we say they are non-touching. So these are some of the things that you need to understand. Now let's consider one question that is asked and let's try to do that. So what is Massen's gain formula first? Massen's gain formula. What is Massen's gain formula? It is E of S by R of S is equal to 1 by delta Pk delta K. Right? Now let's look at this. If there are, let's say, if the P is number of forward path gains, K is, let us say, 2. What do? That is P1 delta 1 plus P2 delta 2 by delta. This is what we write. If K is equal to, that is, if K is equal to 2. If K is equal to 3, number of forward paths, you write, that is E of S by R of S. Transfer function, you write it as P1 delta 1 plus P2 delta 2 by delta. You will also have 3, right? P3 delta 3. Thank you, Rajkumar. Now, let's look at this. The question that is given in the previous university exam. So, let's write the question. It is obtain the transfer function of following signal flow graph. What is that? Let's write that 3, 4, 5 and 6, and this is given as 1, this is given as G1, let's say this is G2, this is one of your question papers, G3, and this is 1 again, and there is a feedback path given. It's given from this output of G3 to G2. So this is minus H3, and here you have minus H1, and this is, let's write this, yeah, this is minus H2. So this is the question, and it's also given that this is C of S and this is R of S. So let's try to solve this. Solution, first thing that you have to write is, write what is the transfer function. Transfer function. What is the transfer function? C of S by R of S. This is the transfer function. The first point. Transfer function is C of S by R of S. This is first point. Second point, Massen's gain formula. Whenever you look at this signal flow graph, you should write Massen's gain formula. What is that Massen's gain formula? C of S by R of S is equal to 1 by delta Pk delta K. 1 by delta Pk delta K. Now let's write this. So next step, third step. First write number of forward paths. Number of forward paths. What are the number of forward paths? Let's look at this. You only have one forward path in this. See, this is starting. There is only one path from this point to this point. Now you cannot take this as, see, let's say this is moving like this. No, it cannot be this, because there is an arrow mark backward direction. So this cannot be the forward path. The only forward path is, you can look this. See the line that I am drawing. So it's better to do something like this. Mark these nodes 1, 2, 3, 4, 5 and 6. When you mark these nodes, it is moving from 1 to 2, 2 to 3, 3 to 4 is the arrow, 4 to 5 is 5 to 6. So this is the arrow. The direction is towards first node to, this is the starting node, this is the ending node. So you can say there is one forward path only. Number of forward paths is equal to 1. What is that forward path? This is the forward path. So this value is 1, I guess. This is G1, G2, G3 and G4. Right? But this is not G4. This is 1, I guess. Yeah, this is also 1. Right. Now write forward path gain. Forward path gain. This is denoted by P1. First forward path. It's from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. P1 is equal to what? G1, G2 and G3. G1, G2 and G3. Now let's write the fourth step. So first step, what do you have to write? Transfer function. Second, Massen's gain formula. Third, number of forward paths and forward path gain. Fourth, number of individual loops. What is that? Number of individual loops. How many number of individual loops? Loops are nothing but they are starting and ending at the same point. Now look at this. Can I say this is moving in this direction and this has one loop? Yes. 2, 3, 2. It is moving from 2 to 3, 3, 2 and 2. So this is one forward path. So first forward path. This is the first one. So it is moving from 2 to 3 and 3 to 2 again. So what is this value? G1. And this value is minus h1, I guess. Right? This is the first loop. Loop 1. Now let's write loop 2. What is a loop 2? Just go back. Do you have any other loop? Yes. You can take this 1, 2, 3. This is moving from 1 to 2, 2 to 3, so 3 to 4 and 4 to 2 again. This is the second loop. So write it down. So it is from 2 to 3, 3 to 4 and 4 to 2 again. So this value is G1, this is G2 and this is minus H2. Now let's write the next value. Is there any other path in this? I can also say that this is another path. Let's say this 3 to 4, 4 to 5 and 5 to, see this is also backward. So 3, 4, 5 and 3. 3, 4, 5 and 3. 3, 4, 5 and 3. So let's write this. So 3, 4, 5 and 3. You can represent this 3, 4, 5 and 3. What is 3 to 4? G2. 4 to 5? G3. This is minus H3, I guess. Now for this, write the loop gains. What do you have to do? You have to write the loop gains. Just that is the product of all the loops, or all the loop gains. So what is L1? Let's write L1. L1 is equal to G1 into H1 minus H1. What is L2 is equal to G2 into H2 minus. Next L3 is equal to G2, G3, H3 minus. So these are the loop gains. How many loops you have? 3. 1, 2, 3. Now, the fifth step is non-touching loops. Fifth step is non-touching loops. So right, so non-touching loops, you can do this. So what are the non-touching loops? Now if you observe these loops, can I say what are the loop? This is 2 3 2. What is this loop? We did not do that. Yeah, 2 3 4, 2 3 4 and 2. Can you say, are there any other loops? If you can see this and tell me if there are any other loops. No, there are no other loops, I guess. And this is 3 4. If you observe 1 and 2, is there a common node in this 1 and 2? Yes. First loop, second loop, 2 and 3 are common nodes. If you observe first and third loop, are there any common loops in this 1 and 3 loop? Yes, 3 is a common node, so these are all not touching. Even if you observe loop 2 and 3, thank you Sanjana. If you observe loop 2 and 3, if you observe loop 2 and loop 3, are there any common nodes in this? Yes, there are common nodes. 3 and 4 are common nodes. So you can say there are no non-touching loops. No non-touching loops in the given question. So you don't have these non-touching loops. And why do you need all these touching non-touching loops? The sixth part you will understand. Here you need to find delta. You need to find delta. Where is delta? This is the delta. In this you can see here, this is the delta part. So let's write the C of S by R of S. How many pk delta k you will get? Generally you will get p1 delta 1 plus p2 delta 2 plus p3 delta 3 plus and so on by delta. Now how many you have to get? That depends upon the number of forward paths. How many forward paths you have in this? If you just can observe, how many number of forward paths are there? Only one forward path is there. In second loop missing G1. Yeah, thank you. Thanks for reminding G1. Right, very good. Rajkumar, very good. Thank you. So here G2, G1, H2. Very good. Now find the delta. So how many number of forward paths are there? One forward path. Let's just go back. And so what is that? P1 delta 1 by delta. This is what we get for this particular problem. This is C of S by R of S. This is C of S by R of S in this particular problem. So let's write that. So let us write that delta. Now what is delta? In simple sense I can say delta is equal to 1 minus L1 plus L2 plus L3 plus and so on plus NL1 plus NL2 plus and so on. This is what you can, in general you can write, and minus you can write it something like this. So most probably in your exams you don't get more than this. So what are this L1, L2, L3? Individual loops. What are this? This is the reason we have written individual loops. What is NL1? Non-touching loop. If they exist you need to write, because they are not existing you need not write. So we don't have this in our problem. So delta is equal to 1 minus, write the values of L1 plus L2 plus L3. I'm not going to do that. I want you to do it, right? So just do this. Now you have, what is the Massen's gain formula you have now? C of S by R of S. What is that? C of S by R of S is equal to P1 delta 1 by delta. Do you know P1 value? Yes, we know the P1 value. If you just observe, we know already P1 value. So you have P1 value here. This is the value of P1. Yes. Do you have delta 1? No, we do not have delta 1. We need to find. Do you know delta? Yes, this is delta. We have already found. So how do you find delta 1? Delta 1 is found from this delta. Delta 1 is found from this delta. Now what is delta 1? Just write delta as it is first. L1 plus L2 plus L3 and check. Where is this delta 1? This delta 1 is corresponding to P1 actually. So what is the P1? This is the P1. We have the forward path. This is 1, 2, 3, 4, 5, 6. Is L1 touching this? This is L1, right? Is L1 touching this P1? Yes, it is touching. So remove that value. You need not write that value. Is L2 touching this P1? Yes. Eliminate that. Whatever the loop that touches this forward path, you need not write those gains again. So do you have L3 touching this? Yes, it is touching. So 1 minus all 0. You'll get delta 1. Let's say if L1 is not touching this forward path, if you have, let's say, second forward path, something like this, 1, 2 and sorry, you just have something like this. From 1, you have, let's say, second forward path, it's 1 to 6 directly. You do not have, this is 2, 3, 4 and 5. if this is one forward path, second forward path. Now, does this loop 1 touch forward path 2? No, you have to write that value of L1. So this is how it will be. I have just taken an example. This is not the case in our particular problem, right? Now, what is delta 1 value is equal to 1. So let's write the complete transfer function. What is that transfer function? C of S by R of S is equal to P1 delta 1 by delta. I have just taken a small question from your previous question paper, so that's how we got it as a simple value. What is P1? Let's see what is P1 value. G1, G2, G3. Simple G1, G2, G3. Let's write that. G1, G2, G3. What is delta 1? 1. What is delta 1 minus? Write these values of L1 plus L2 plus L3. So let's write that. C of S by R of S is equal to G1, G2, G3 by 1 minus. What is L1? Minus G1 H1. So this is minus G1 H1 minus what is L2 minus G1 G2 H2 minus G1 G2 H2. What is L3 minus G2 G3 H3 minus G2 G3 H3. Is it so? Yes. So finally you can write C of S by R of S is equal to G1 G2 G3 by 1 plus G1 H1. Is it G1 H1? Yes. Plus G1 G2 H2 plus G2 G3 H3 is the required transfer function, right? So this is the required transfer function of the given question. So this is one of the important questions. You can, although in the new syllabus this part is not given as signal flow graph, it is one of the important questions, I can say. Hope you must have understood all these things well, and thank you all for once again joining me today on this session. So we'll continue the same, and the second chapter will be discussed tomorrow and day after tomorrow, and I want everyone to join me tomorrow as well. So once again we have discussed today block diagram and signal flow graph and electric circuit transfer function as a part of chapter 1 control systems. So as I always tell you, we have #1 study channels on Unacademy, and like this video, share this video and subscribe, and use my code YSK10 to get maximum discount on Unacademy subscription. Hit on this bell icon to get more notification of my classes, and you can also join our Telegram group for more updates. Thank you, Rajkumar, and let's crack GATE and ESE. Thank you so much.